Hello, everyone. Welcome to this session. I'm Xianning Liu.
Hey, I'm Aaron, and today we're going to talk about our thoughts on how to deliver a mobile application.
Okay, so our agenda will be, firstly, I will do a quick and general introduction about the mobile project lifecycle, and in each stage, the methodologies and the practices we used when we deliver it. Then Aaron will talk about that how to choose the mobile tech options. So generally, I will dig a lot of rabbit holes. Then Aaron will fix one of them. And all the others, we welcome your questions to all the other things, but it's offline because of time sense. Okay? So let's move to the first one. For mobile project overview. When we start a mobile project, firstly, we always were working with the business people and the UX people to define why we build this mobile product, what this product will look like, and what kind of device capability it will use. Then, in this stage, the UX people, they will focus on the philosophy behind the font, behind the size, the user journey. As a techie, I always focus on how to do the componentization and how to make sure that, or how I can make more reusability on this project. So generally, I will do firstly, I will use the atomic design methodology to split the user flow they designed to small pieces. Then use the logo style component architecture to group all of them back to the product. Then because we split it, all these things into components, then we can build a living style guide sense to show how many components we already have and what each component will perform. Then based on this living style guide, the UX and the dev, they can communicate very efficiently to understand what I designed is what you implemented. So in this stage, after we defined what the product will perform, then the next point I will think is about how the backend can support my product. In most of our projects, we face this is the hardest part because the backend has so many dependencies and blockers. So normally we will do is, firstly, we will do the BFF to aggregate the backend service. Then because the backend business model data, they are not one-on-one match with our view model. So generally, I will build some kind of embedded mobile anti-corruption layer to split the concerns between the business data with the UI model, which will make the UI view model, makes the UI can be purely like a function. So we can achieve the data-driven UI. So I give you this data, the UI will definitely show it like that. And that can help me to control the app state. Then the next part is that in our project, normally we were developing the API and the mobile in parallel. So how we can make sure that when I develop a mobile, I will not blocked by the backend developing. So normally we will use some kind of standalone mocks like multi-bank, like WireMocks. But in some projects, actually the mobile experts, most times they focus on mobile. They are not quite easily to maintain a standalone repo for the mocks. So we use some kind of embedded mobile mocks that we develop in a separate network layer that you can easily to inject some kind of mocks there to help you just focus on your mobile component development. Okay, so after we figure out this, we will move on to the next decisions. Choose the right tech stack for your product. In this one, we will use the information we got when we do the product discovery. So I will skip this one because Aaron will figure out this rabbit hole in details later. Then let's assume that we already choose the tech stack. So the next part is applying some kind of engineering practices in your delivery pipeline. So except the traditional CI/CD practices, in mobile, they have some specific things need to handle. So generally, for mobile, the specific things is that you need deliver your code to the real devices to test it. So mostly we say in the mobile delivery project, we can say that the code be blocked a lot because they can't find the right test device. They can't easily figure out that which version they are testing now. And they can't easily to switch the test environment, the backend endpoint in the app. So we designed this kind of strategy to make sure this kind of things didn't block QA. And then is that in mobile, the toggle implementation also will be hard. And also in most of our mobile project, we say that they merged the dynamic configuration for the app with the toggle. They just use one configuration to control toggle and the dynamic configuration. So we're trying to make sure that you split your toggle is toggle, dynamic configuration is dynamic configuration. And also with the dynamic configuration framework, you can easily to achieve the A/B testing framework in mobile side. And the last part is mobile growth. We know that we build this kind of continuous delivery pipeline. We are not trying to continuous delivery is not the code, it's the customer value. So how we can achieve that? So in the mobile growth, there's a lot of tricks. But for this one, I just want to emphasize is that we will build some kind of data collection component that will help you to collect the right and enough data and feed this data back to the first stage. That make your mobile product life cycle in a virtual cycle. That this is always running. That can help you build your product continuously. So mostly that's my part. So I will move the controller to Aaron. Yes, thank you.
Thanks. We had a nice overview of many of the decisions that you have to make when you're starting a mobile app. And today I wanted to talk about one of the biggest questions that we get when we're kickstarting a project, which is which of these options you should use. The line between them is a little bit blurry, especially since you can mix and match them in a variety of different ways. That said, there's generally these 5 different categories. So the first one is just a standard HTML5 responsive website. Many of you probably know what this is. It's called responsive because it responds to the user's environment. Most importantly, it responds to different screen sizes, but it can also respond to other things like interaction modes and connectivity states. Responsive website, it's really important that it has good CSS to ensure that the site is appropriately sized. You also use advanced image strategies to make sure that the images look crisp and clear even on high DPI screens. That's basically a responsive website. It's typically your cheapest option of the 5, and you can usually get something to market the fastest this way. If you want, you can also build a progressive web application. This is a newer technology. It's basically a responsive website, but it has some extra features added to improve offline usability, speed, and user engagement. Unfortunately, it's not widely supported by all browsers yet. So if you're building a PWA, you're primarily going to be benefiting Android users and people on Windows tablets, although iOS users will see some benefit from this. Although it's not required, typically you can add some other mobile-like or native-like features to your PWA, such as Apple Pay, geolocation, and sharing user credentials between a web app and a native app. The next option that's sort of in the middle is a hybrid app. There's a whole bunch of different kinds of things that are called hybrid, but at their core, all of them are basically you have a native app, it's deployed through an app store, but you have a web view that you're using to render and display content. In the simplest approach, you basically have the shell of a native app, and then everything else inside it is a web view. There's some more advanced approaches where you can iteratively start with web content and then switch in native experiences as you determine what your users like. The most popular tool for this is Apache Cordova, but given the advances in PWAs and the advantages of cross-platform apps over hybrid, it's really hard to think of a new project where I would kickstart it as a hybrid app. So for not too much more effort or cost than a hybrid app, you can get a cross-platform app. This does have what some projects may consider an upside and some may consider a downside is that from here on to the right, you're deploying through an app store, like Apple's App Store or Google Play Store, whereas the first two options are going to be deployed on a website. This has a couple of great benefits. One of the biggest benefits is if you have a team of developers who already knows a language, say you have a shop full of C# developers who know .NET, you might want to pick something like Xamarin and build a cross-platform app so you don't have to train them on Java and Swift. But there are some downsides. These tools can lag behind the official tools, which can reduce your ability to adopt new technologies as Apple and Google release them. Also, some of these cross-platform tools like React Native render UI at runtime, which can make the experience a little bit laggier. Even though it's a native app, it'll be leaps and bounds ahead of a website. It can still be like a couple milliseconds slower. For most use cases, this is imperceptible. But where performance is really key, you might want to go fully native. This is interesting in particular because Airbnb and Udacity recently announced that they're both moving away from React Native and all the way right towards the fully native app approach. So this is going to be a really expensive change for them. And so it's important to think of this stuff up front because if your app is really complex and you have a cross-platform app in one language and then you're building these bridges into Swift and Java code, you can end up actually maintaining 3 significant code bases instead of just an iOS and an Android one. So although it can give you a lot of quick wins, there is some additional complexity. And then finally, all the way on the right, we have our fully native app. So this just means you're basically using the mobile operating system's preferred tool chain. So if you're making something for iOS, you're using Xcode and Swift. If you're making something for Android, you're using something like Java or Kotlin and Android Studio. This approach is going to give you the foundation for the highest possible quality application. Graphical and app performance are going to be highly tuned, really fast, really responsive. When new stuff comes out like Touch ID, Face ID, this is where you're going to get to interact with it first. Stuff like that doesn't typically make it to the web until later. But of course, there are some drawbacks. The primary drawback is that it's more expensive. According to a study from Robert Half Technology, which is a global recruiting firm, salaries for a senior mobile developer is about 20% higher than a salary for a senior web developer. So it can be hard to staff these teams, especially if you don't have a strong business justification for spending the extra money. And even when you get a really good team, sometimes the delivery can be slower because it's still harder work. So a sort of naive look at this, if you're just this sort of spectrum, is that on the left you have the stuff that's the cheapest and the fastest. On the right you have stuff that's hardest, but it might come out better. This is obscuring a lot of the complexity of the decision and also obscuring the fact that you can mix and match this stuff. Like you could have a fully native app with a responsive website as one tiny part of it. There's obviously a lot of nuance to it. So we recently published on ThoughtWorks Insights, which is our blog at thoughtworks.com/insights, a list of guidelines that you can consider if you're starting a mobile project to help you decide between these. I picked out 5 of them to talk through real fast. These are probably the 5 biggest in my opinion, although there are others, and the blog has a little bit more flavor to these. So the first is leverage developer familiarity. So like I said at the beginning, if you have a team of devs that know C#, they can probably get up to speed really fast using something like Xamarin, rather than training them on Swift or Java. So even if every other sign is going to point you to a fully native app, you may want to stick to a cross-platform app for that reason. If your app is going to be a strategic advantage, that means it's going to give you a long-term leg up over your competition. I'd prefer fully native, where if it's something more tactical like a bill pay app, that may be less important. If your app has reusable user interface components, you don't really feel the need to follow the Google and Apple user interface guidelines very strictly. You could prefer cross-platform if you don't need to do a lot of customization. If your application is just an experiment, you haven't really found market fit yet, definitely consider responsive or PWA because you can iterate faster, you can get to production faster, and it's less expensive. And then finally, if there's lots of competition in the market for your product, prefer something fully native because that will let you adopt new innovations really quickly. Like I said, there's a lot more of these guidelines and some more flavor about them, and we'd love to hear what you think. Thank you so much.